In the last lesson, I explained why it's useful to have the ability to do generic programming. And the example I gave was a couple of arrays that we created and that we wanted to display with a function, and because the arrays are of different data types, we had to create two different functions, display and display string. With generic programming, however, we could have just one function, display, that would work for any data type. So in this lesson, we're going to learn how to create generic functions. The first thing we're going to do is move up to our function definition for display, type in the keyword template, followed by an open angle bracket, less than sign, the keyword type name, and a type placeholder, which we'll use T as that placeholder. And that's a convention to use T because it represents type. Now, all we have to do is wherever we have a reference to the data type that we want to make flexible or generic, we just put T in its place. So for our int array parameter, we change that to T array. And now at runtime, the compiler will replace T with the actual data type of the array that's passed in as an argument. So because we've made display generic, we can actually get rid of display string. Right here, we can come down to our main program and change display string to just display. And now our program should, using one function, display both our int array and our string array. So let's build and run the program. And there we see, let me pull it into view, that we have the numbers and the names using one single function call. So that in essence is how generic function programming works. Let's look at one more example just to reinforce the idea. What we'd like to do is be able to check to see what is the maximum value of two values of the same data type. For example, two numbers or two strings, say we're doing some sort of sorting program. So we can do that by creating a generic max function. So the first thing we do is start off with template type name T. Now, because our max function is going to return data, it won't be a void function, we're going to put T where the return data type is for the function definition, followed by the name of the function, max, followed by T for our first parameter data type. And then we need to make these references because we might be working with numbers. And our compiler will give us a hard time if we don't make the parameters references. So we use reference types for arg1 and arg2. But our code is very simple. If arg1 greater than arg2, return arg1, else return arg2. And close off the function. Let's comment out the other program, or the earlier program that we wrote. And then let's test this out with a couple of data types. We'll say int a equals 12, int b equals 24, cout max ab, indel, double x equals 2.25, double y equals 0.25, cout max ab, indel. And then string w1 equals apple, string w2 equals aardvark, cout max w1 w2 indel. So we build and run. Oh, I see. Slight little mistake. X and Y for the second call to max. Build and run again. And there we go. Let's pull that into view. There it is. So we see that 24, 2.25, and apple are the max values in each of these calls to max. And we did all three calls using the same function that's defined as a template. And there's the definition again. So to review, we begin a generic function with the template type name T, and then every place in the function definition where we want a flexible or generic data type, we replace a specific data type name or the specific data type name with the placeholder T. And again, T is just a convention. We could use anything, but T is what you'll see most often in the literature, and it makes the most sense. So that describes how you create generic functions. Now we're going to increase the complexity a little bit and talk about how to create generic class definitions so that we can create classes that will work with flexible data types. And we'll see how to do that in the next lesson.